Okay. Okay, so for linear differential equation, okay, so general form for linear first, so ni second type of differential equation. Yang first type for separable differential equation. Okay, so yang separable differential equation ni yang last week separable general form dia in terms of dy over dx. Okay, you have dy over dx equal to gx times with hy. Okay, so ini general form of the first step, first order differential equation, yang separable differential equation. Okay, separable DE. Okay, separable differential equation. So ini kalau you nak solve dia, you solve using separable method lah. You separate kan, lepas tu you integrate both side. Okay. Okay, so ni separable DE. So for linear first order differential equation, general form dia is in terms of a1x dy over dx plus a0 y equal to gx. Okay, so dependent variable y in equation and its derivative dy over dx are of first degree. Okay, so you punya dy over dx ni is in terms of first degree and first order. Okay, lepas tu you ada satu variable y. So variable y ni dia tak mesti spesifik y. Dia boleh jadi x ke z. So cuma dia mesti dependent. Okay, so ini is for dependent variables. Okay, so depends on your equation. So kalau dependency y, so kat sini is y. So if the dependence equation dependent variables to z, so this one becomes z lah. Okay, so ini for linear general form dia. Okay, so so teknik dia, so we need to divide both sides of general form by the leading coefficient of a1x. So for example, you have dy over dx2, you ada term x dy over dx. Okay, so kalau you ada term ataupun coefficient for dy over dx, then you need to divide with x. Okay, so ini kita nak remove the coefficient. So for linear first order differential equation ni, the coefficient for dy over dx dia must be 1. Sebab tu kita divide balik dengan dia punya coefficient. Okay, lepas tu you ada px. Okay, so px yang inilah you punya px. And we also have qx. So qx yang belakang ni. Okay, then we will obtain the standard form of linear differential equation. Okay, so nanti kita akan dapat bentuk ni lah. So ni you kena hafal Okay, standard form of the first order linear differential equation in the variable y. Okay, so the coefficient of dy over dx is 1. So kalau tahu coefficient for dy over dx ni, dia mesti 1. Okay, lepas tu we have integrating factor. So integrating factor formula is I exponent and integrate dx dx. So ni pun you kena hafal formula for integrating factor. And yang atas ni is the standard form dia. Okay. So saya nak you refer to example 11. Okay, you need to find the integrating factor for x dy over dx plus with x plus 1 y equal to 3. Okay, so kalau you refer first step, dia mesti coefficient for dy over dx tu must be 1. So you kena divide dengan x lah. Divide dengan you punya coefficient tu. So over with x, this one over with x. Okay, so you will have dy over dx plus with x plus 1 over x, we have y equal to 3 over x. Okay, so coefficient of dy over dx tu jadi 1 ke sini. Okay, next saya nak you compare with standard form. Okay, compare with standard form, you have dy over dx plus pxy equal to qx. Okay, nanti you will derive what is the px. Okay. Okay. Okay, so compare with dy over dx plus pxy equal to qx. Okay, so saya nak you identify what is the function px. So kita mesti ada px. So kalau you compare, you have x plus 1 over x. So yang ni represent you punya px. Okay, so you have px is equal to x plus 1 over x. Okay, you simplify x over x plus 1 over x becomes 1 plus 1 over x. Okay, so ni punya px. Next, kita boleh calculate lah integrating factor. So integrating factor equal to formula integrate px dx. Okay, so equal to integrate px is 1 plus 1 over x dx. Okay, so integrate 1, you have x plus 2 plus with ln x. Okay, and we can simplify. So ini using rules for indices. Okay, so you have ex times with e ln x. Okay, so e dengan ln you boleh cancel and then you will have x times ex. So ni you akan dapat x je lah. So x times with ex. Okay, so ini you punya integrating factor. Okay, so ini for example 11. Next, for example, okay, so kita nak solve yang ni baru you calculate integrating factor. Okay, so next kalau kita nak solve for differential equation. Okay, so we have step 1. Okay, step 1 we need to write in the form of, in the standard form. Okay, so ni is the standard form. Okay, so coefficient of dy over dx is 1. Okay, so step 1 ni sama tadi lah. Okay, ni so you must write down in terms of standard form. Okay, next step 2. Okay, identify px. Tadi pun kita dah saya tunjuk tadi, identify px and then find the integrating factor. Okay, so ini formula for integrating factor. Next, for step 3. Step 3, you need to multiply both sides of equation 2 by 1. So maknanya you need to multiply, by integrating factor. So step 3 ni, you need to multiply integrating factor, multiply with the equation 2. So equation 2 ni yang you punya standard form tu. You dah tukar in terms of standard form. Okay, so you multiply integrating factor dengan standard form. So observe that the left hand side of the resulting equation is the exact derivative of the product between integrating factor and dependent variables. Dia tak semestinya y, maknanya integrating factor times with the dependent variables. Okay. So ini untuk you punya left hand side. So after you multiply tadi, okay, you will derive you punya product rule. So formula is integrating factor multiply with the dependent variables. So ni is the dependent. Okay, dependent variables. Lepas tu right hand side pun sama. You kena multiply dengan integrating factor. So you kena integrate both sides. Okay, so step 4, integrate both sides and then solve for y. Next, nak you refer to example. Okay, example 50. Okay, so example 50 sama macam example tadi. Tapi ni kita nak solve for y. Kita nak calculate what is the equation for y. Okay, so from dy over dx ni. Okay, so kita pergi step 1. Ini saya repeat balik lah yang tadi. So step 1 you kena divide with the coefficient for dy over dx. Okay, so equal to 3. So all each term tu saya divide with x. So you will have dy over dx plus x plus 1 over x, y equal to 3 over x. Okay, lepas tu you nak determine the integrating factor. So tadi px dia, saya dah state dah, px is x plus 1 over x. So you will have 1 plus 1 over x. Okay, so step 2. Step 2 you need to determine the integrating factor. So tadi formula dia is I integrate px. So px is 1 plus 1 over x. Okay, so tadi saya dah solve dah, you akan dapat ex plus ln x. So also equal to ex times with e ln x. So equal to x ex. Okay, so ni for your integrating factor. Next for step 3. Okay, step 3 multiply integrating factor ni yang you calculate pada step 2, you multiply with the standard form ini. So you jangan multiply dengan yang original differential equation. You multiply bila dy over dx dia jadi 1. Coefficient for dy over dx dia 1. So kita dapat standard form. So you multiply every term with integrating factor. So you will have x ex dy over dx. So plus with, okay, so saya multiply semua dengan integrating factor. Okay, so equal to x ex times with 3 over x. Okay, so you simplify, becomes, you have x ex, so plus with ex, x plus 1 y equal to 3x ex over x. Okay, so ini kita nak derive pada left hand side. So ini. So left hand side ni actually dia comes from the product rule. So product rule maknanya kita nak calculate balik what is the UV. So kalau you ingat balik product rule yang chapter 1, okay, for example you ada UV, for example you have U and V. So ni product rule, nanti you nak solve dia to find dy over dx, you kena solve using product rule yang UV prime plus dengan V prime. Okay, so you punya question is for example 15 ataupun differential equation ni, untuk yang linear punya, dia akan bagi you for chapter 1 hari tu from UV, you nak derive kepada product rule. Tapi untuk this chapter, dia akan bagi you the result of the product rule tu. So you kena derive balik what is the question. Okay, sebab tu lah ni. So yang ni semua is the product rule yang atas ni. So ni comes from UV prime plus dengan V prime. Okay, so saya nak redah balik dia punya soalan dia ataupun dia punya UV ni. Okay, so formula dia is I, maknanya integrating factor. So integrating factor ada x ex. So you need to multiply with the dependent variable. So dependent yang atas ni y. So you need to multiply with the y. Okay, so you dapat dah you punya UV. X multiply, so you have 3ex. Okay, lepas tu after you dah derive product rule tu, so you need to integrate both sides. Okay, so kita ada step 4. Okay, saya nak integrate d over dx. So tadi saya ada x ex times with y, so equal to integrate 3ex dx. Okay, so ini integrate and differentiate, so automatic boleh remove. So you copy je So you have x, e, x, y. So equal to this one, integrate dapat 3ex plus with c. Okay, so to find y, so y is equal to 3ex over xex, c over xex. Okay, so y is equal to 3 over x plus with c over xex. Okay, so ini punya y. Di sini for example 18. Okay, next example. So example, sorry, tadi example 15. So ni example 16. Okay, sama juga you have differential equation. Lepas tu you are given initial condition. So example 16 initial condition. So pi ni represent value for x and another pi represent value for t. Okay, so value for t. Okay, so sama juga first step dia. Okay, so the coefficient for dx over dt tu must be 1. So you need to divide with t lah. So over with t. So minus with x over t equal to t power 3 cos t. Okay, so divide by t. Okay, so you will have dx over dt. So minus with x over t equal to, so you nak simplify t square t cube cos t over t. So you kena simplify to based on the types of the function. So kalau algebraic, you need to simplify with the algebraic lah. So cos t ni you tak perlu tukar, tak perlu simplify sebab dia trigonometry. Okay, so yang ni t cube divide by t, you will have t square cos t. Okay, so ni you dapat you punya standard form. So ni kita panggil standard form lah. Lepas tu you boleh compare with the you punya general standard form tu. So kita ada dx over dt. So plus with ptx equal to qt. Okay. Lepas tu saya nak you determine what is the pt. So pt is equal to negative 1 over t. Next to you punya pt. Next we move to step 2. Step 2 determine integrating factor. So e integrate px dx. Okay, so equal to e integrate px negative 1 over t dt. Okay, so e negative ln t. Okay, so negative e dengan ln ni dia tak boleh ada in between. Dia tak boleh ada term. Okay, so negatif ni you transfer dulu pada t. So you will have e ln t negative 1. Sebab negatif kat depan ni dia also represent negative 1. Okay, lepas tu baru you boleh cancel. So bila e dengan ln tu side by side, baru you boleh cancel lah. So you will have 1 over t. Okay, so ini punya step 2. Next step 3. Okay, so step 3 you need to multiply integrating factor with the standard form. Okay, so integrating factor you ada 1 over t. Lepas tu you punya standard form yang ini. Yang coefficient for dx over dt tu dah jadi 1. So dx over dt. Okay, so ni punya step 3. So 1 over t and dx over dt. Lepas tu you ada minus x over t. So minus 1 over t times x over t. Lepas tu equal to 1 over t times t square. Multiply dengan ini So 1 over t times kan dengan cos t. T square cos t. Okay. So for the left hand side ni, represent product rule. So formula dia is d over dt. Okay, so formula is integrating factor. Tadi kita ada 1 over t, integrating factor dia. So you need to multiply with the dependent variable. So in this case, dependent variable is x. So multiply with x. Okay, equal to, so ni boleh simplify t with t square, so you will have t cos t. Okay, so for the left hand side, okay, so nak integrate so you nak integrate both side. Okay, so ni consider as step 4 ni. Okay, so you ada step 4. Okay, so you will have x over t equal to t cos t. You need to solve using by part. So u dia is t and du over dt is y, and you have dv is cos t and v is equal to sin t. Okay, so kita substitute dalam formula uv minus integrations of v du. So u dia is t, v is sin t, so minus with integrations of v sin t du is dt. So you will have t sin t integrate. Sin dapat negative cos, so dapat plus cos t plus with c. Okay, so to find x is equal to t square sin t plus t cos t plus with c. Okay, tapi dia ada bagi initial condition, so you boleh substitute je. So initial condition dia is x equal to pi and satu t also equal to pi. Okay, so you punya equation is x, so saya write down balik, t square sin t plus with t cos t plus with c. Okay, so substitute x dengan pi. So pi equal to, so t also dengan pi, sin pi plus with pi cos pi plus with c. Okay, so to find sin pi, mode calculator you must be in radian. So you tukar mode calculator you dalam radian, lepas tu you boleh calculate sin pi. Sin pi is equal to 0. So you have pi. So pi square sin pi 0, so plus with pi. Cos pi also you can find using calculator. Cos pi is -1 and plus with c. So you have pi. Okay, so c is equal to, so pi equal to negative pi plus c. So c is equal to 2 pi. Okay, so you dah c equal to 2 pi, substitute balik dalam you punya general solution. So you will get particular solution. So x plus with t cos t plus dengan 2 pi. Apa?
Bukan
Sorry.
C.
Apa dia?
Bukan plus CT yang ujung.
Plus C3.
CT. Equation.
Plus CT. Okay. So ni plus CT kan? Oh sorry, betul. So ni plus CT. CT betul lah. So plus CT. So substitute T dia dengan pi. So kat sini CT. So kat sini ada pi lagi sekali lah. So you will have C pi. Okay, betul. So nanti you akan dapat C pi equal to 2 pi. So you boleh cancel pi, C is equal to 2. Okay. So you punya final answer, you ada T square sin T. So plus dengan C dia is 2. So you will have 2T lah kat sini. Sini plus with 2T. Okay. So ini untuk example 16. Okay, ada soalan tak?
Madam, memang dekat bahagian tu kalkulator mode radian
Apa dia?
Memang dekat bahagian tu kalkulator mode radian.
Betul. You kena calculator tu mesti mode radian sebab pi tu is a radian. Dia kalau you nak calculate contoh, dia bagi angle kan, dia bagi you punya initial condition tu, dia bagi in terms of degree. Okay, contoh dia bagi you punya initial condition, dia bagi you dalam bentuk degree. Tapi saya rasa tak pernah lagi bagi dalam degree. Tapi contoh contoh you punya x tu, value of x tu in terms of degree, x tu 60 degree ke, or you ada value of t tu, t tu you ada 30 degree. So kalau dia bagi in terms of degree, baru mode calculator you tu in terms of degree jugalah. Tapi kalau pi ataupun dia bagi values numbers, contoh dia punya initial condition x dia 2 equal to 4. So ni pun mode calculator you must be in radian. Tapi yang ini dia, you punya mode calculator tu dia effect kalau trigonometry je. Dia kalau function yang involve trigonometry, baru you kena hati-hatilah dengan you punya mode tu. Sama ada you pakai radian ataupun you pakai mode dia degree. Okay, so nak tengok mode dia mana satu, you tengok you punya initial condition tu. So initial condition tu dalam numbers macam ni, or in terms of pi, so mode calculator you must be in radian. Tapi kalau you punya condition tu in terms of degree, then mode radian you, and then mode calculator you in terms of degree je lah. Okay, dia hanya kalau trigonometry. Kalau example 15 tadi, example 15 ni tak ada trigonometry kan. Dia just function algebraic biasa, terus tak kisahlah mode calculator you tu. So kalau equation biasa, dia tak ada effect, sama je mode dia degree ke ataupun radian, so you akan dapat answer yang sama. Okay, dia kalau yang involve function trigonometric tu je, so you kena hati-hati lah kalau trigonometric. Okay, boleh?
Boleh madam, thank you.
Okay, so lagi soalan? Tak ada tak? Okay, so you punya chapter 5 untuk kelas kita akan cover 5.1 and 5.2 je. So start from 5.3, itu saya tak cover untuk lecture lah. 5.3 tu you kena study sendiri untuk you punya assignment. Okay, so 5.3 final tak ada so you punya final until untuk chapter 5, 5.1 and 5.2 je. Okay. So sekarang saya nak masuk chapter 7. Okay, chapter 6 pun saya tak cover. So itu tu you punya assignment. Okay, so for chapter 7. Okay. Okay, so chapter 7. Okay, so chapter 7, the last two chapters ni, chapter 7, chapter 8 ni, dia chapter for statistik So statistik ni biasa solution dia tak panjang, dia tak macam you nak solve for differential equation ke, you nak solve for by part atau substitution. Okay, so untuk chapter 7, chapter 8, solution dia biasa dia simple je, dia punya calculation pun simple calculation. Okay, tapi you kena faham lah dia punya soalan tu, dia nak apa. Okay, so tu untuk chapter 7 and chapter 8. Okay. So for chapter 7, is probability and random variables. So for this week, saya cover probability. Okay. And next week baru kita akan masuk random variables. Okay, so learning outcomes. Okay, number 1, determine the events and sample space of a probability experiment. Number 2, distinguish the type of event. So event, we have complementary, mutually exclusive, dependent, independent, and conditional event. So number 3, we need to determine the probability of event using probability rules and tree diagram. So number 4, solve probability problems using counting rules. So number 4 ni sebenarnya dah tak ada So counting rules ni sebenarnya refer to permutation and combination. Permutation and combination untuk batch dah 2 batch dah sebenarnya, dah 2 batch. You batch yang kedua lah. So memang dah tak ada, dah remove topik ni sebenarnya. Okay. So dia tak ada untuk counting rules, tak ada. Okay, so number 5, distinguish between discrete and continuous random variables. So dia dah masuk random variables. Ini untuk next week ya, number 5 ni. So number 6 pun for random variables. Okay, we need to determine the probability distribution function for discrete random variables. Number 7, determine the probability using the probability density function for continuous random variable. And last, calculate the expected values, variance and standard deviation for discrete and continuous random variables. So step for number 5 ni, 5 until 8 ni untuk next week. Okay, so for this week kita cover 1 until 3. Okay, so we have 7.1 basic concepts and rules in probability. So you ada keywords there. So probability a value between 0 and 1. Ni pun saya dah familiar dah. Sekolah pun dah belajar probability kan. So kita tahu probability tu value dia must be between 0 and 1. Okay. So equal to 0 boleh or equal to 1 pun boleh. So dia tak boleh more than 1 or less than 0. Okay. So itu for probability. And next we have probability experiment. A process involve chance that leads to one of the several outcomes. So for example eksperimen, contoh you ada eksperimen, you toss a coin. So ni you punya eksperimen lah. Okay. Lepas tu you ada outcome dia. So the result of a single trial of a probability experiment. So result outcomes tu you punya result daripada you punya eksperimen. For example, you have tossed a coin. So result dia is equal to you have head or tail. Okay, so result of the single trial experiment. Lepas tu kita ada sample space. So sample space the set of all possible outcomes. So sample space tu sama macam outcome tapi dia punya notation. So for sample space we have capital letter S. So you punya outcomes you write in terms of curly bracket. So for example you have S. So you ada curly bracket and then you have head and tail. Okay, so ini for sample space. Okay, so sample space memang fix ya. Dia mesti pakai you punya S. So S tu, capital letter S tu represent sample space. Kalau event ataupun eksperimen, dia tak spesifik lah. You boleh pilih any letters, capital letter. Okay. So next we have sample point. So individual outcomes in a sample space. So NS is the number of sample points in sample space. Okay, so for example, kalau you ada sample space the head and tail, so total you pakai NS lah. So N tu refer to the total of the sample space. Berapa you punya outcomes tu. So kita ada 2. Okay. Next we have event. So event a subset of a sample space. So denoted with capital letters other than P or S. Okay. So P ni is probability. Okay. So untuk event dia subset untuk you punya eksperimen. For example, you toss the coin. So event dia you boleh assume contoh saya ada A. So A is getting a hit. So kalau tengok A ni is the event. So event ni dia mesti subset kepada you punya eksperimen. Okay. Next in terms of Venn diagram. Okay, so ni between event and sample space. Okay, so yang luar ni is the sample space. So ini is the event. So kalau you refer Venn diagram ni, so you can see that the event is the subset of the sample space. Okay, so ini eksperimen example dia. So roll a die once. So outcomes there we have 1 until 6. And we can write down in terms of sample space. So you ada capital letter S, lepas tu you letak in terms of curly bracket ni. So dalam dia sama you punya outcome lah. Lepas tu you ada possible event. So possible event ni is the subset of the experiment. Okay. So dia nak odd number observe. So you nak tengok you punya outcomes for the event, you boleh refer balik you punya sample space. Sebab tu you punya probability biasanya before you solve, okay, you kena write down dulu sample space dia apa. Sebab nanti bila you nak tulis outcomes untuk event, so senang, you boleh refer pada sample space je. Okay, so kalau odd number, you refer sample space, kita ada 1, 3 and 5. Okay, so untuk eksperimen number 2, so toss a coin twice. So you have head, 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 tail, head and tail, tail. Okay, this really comes from tree diagram. You ada head, tail, so you ada head, tail and head, tail. So you ada head, 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 tail, sampai you dapat tail, tail. Okay, so sample space dia equal to the outcome. So event is getting 1 head. So you refer balik you punya sample space, getting 1 head, we have 2 head, tail and tail, head. Okay, next the number of defective items coming from a production line every hour. So we have 0 until infinity kat sini. Okay, so sama juga sample space, lepas tu event dia less than 3. So less than 3 is 0, 1, 2. Lepas tu you ada measure the weight of newborn babies. Okay, so example you have 1 to 6 kg. Okay, so ni can write down in terms of sample space. You boleh buat dalam untuk interval. Okay, so X ni represent the weight and at least 2.3. So X dia less and equal to 2.3. So ini bukan at least, ini at most. Okay, so you refer buku you sudah show, dah tukar tau. So ini at most 2.3. So kalau at most, X2 must be less and equal to 2.3. Okay, so last experiment, labeling 10 cards from A to J. So outcomes dia from A until J, so sampai dengan sample space. So select vowel card, you refer to sample space. So vowel you have A, E dengan I. So we have 3. Okay, so from example 1, notice that the sample space can be discrete or continuous. So discrete ni biasa benda yang kita count, you kira. Okay, and continuous ni biasa kita measure dia. Okay, so kalau you tengok kat sini, roll a die ni you boleh kira, toss a coin pun you boleh kira, number of defective, so number defective pun you boleh kira. So maknanya number 1, 2, 3 ni semua for discrete. Tapi kalau eksperimen number 4, measure the weight, so weight ataupun kita ada height ataupun length, tu semua tu kita tak boleh kira, kita measure. Okay, so semua yang measure weight, height ataupun you ada length, semua tu consider as continuous. Okay, so untuk eksperimen ni sample space yang continuous is only yang ni, number 4 je. Okay, yang number 5, labeling 10 cards ni is a discrete. Okay, so you boleh kira. Next, quantitative or qualitative. So quantitative, you boleh refer pada you punya sample space tu. Quantitative ni in terms of numbers. You punya sample space tu in terms of numbers. Kalau qualitative, sample space tu in terms of characteristic. So karakteristik tu maknanya dia based pada contoh colour ataupun you ada letters, tu based pada karakteristik lah. So kalau numbers, contoh dia macam number yang first ni. So ni semua you punya sample space in terms of numbers. Sama juga yang number 3. So ni pun in terms of numbers. Okay, maknanya ni quantitative lah. So yang number 4 pun numbers. So yang quantitative you have 3. So ni quanti. So yang ni pun is quanti and this one pun is quantitative. Okay, tapi kalau kualitatif ni yang based pada karakteristik, contoh kita ada yang number 2, head tail ni. So ini is qualitative. So qualitative. Okay, lepas tu you have last experiment A until J. So ini pun bukan in terms of numbers. So dalam bentuk karakteristik, so ini pun is qualitative. Okay. Next, kita ada finite or infinite. So ni senang je. Kalau finite maknanya you punya outcomes tu dia ada ending lah. So kalau finite, outcomes tu ending. Kalau infinite, so outcomes tu doesn't have ending. Okay, contoh dia for finite, so eksperimen number 1 sample space yang ni finite, so yang ni pun finite, so this one finite, yang ni pun finite. Okay, so yang infinite is yang number 3 ni, sample space yang number 3. Okay, so kalau tengok kat sini, you punya outcomes tu dia until infinity. Okay, dia tak ada ending. Okay, so kalau tak ada ending, kita consider as infinite. Okay, and last, sample space dia exhaustive. So they must include all possible outcomes from experiment. Okay. So tadi you punya classification lah untuk you punya outcomes ataupun eksperimen dengan sample space. Sekarang kita nak masuk 7.1.2 interpretations of probability ataupun types of probability. So types of probability we have 3, classical or theoretical, number 2 empirical or relative frequency, and last is subjective probability. Okay, so kita pergi classical dulu. So classical probability. Classical probability assumes that all outcomes in the sample space are equally likely to occur. So equally likely tu maknanya dia punya probability tu is equal lah. Dia sama je. Tak kisahlah you ada outcomes tu you ada 10 ke. So kalau 10 outcomes, every outcomes tu probability dia is equal. Okay. So this means that if there are n sample point in S, then the probability of each sample event in S is 1 over n. Okay, so example dia kalau you ada head dengan tail tadi, you toss a coin. So kalau you ada head dengan tail, so probability you dapat head is 1 over 2, so probability you dapat tail pun is 1 over 2. So dia tak bias lah. Okay, so ini pun example of the classical. Ataupun you toss a dice, pun die. Okay, you ada 6 kan, so face you ada 1, 2, 3, 4, 5, 6. So each outcomes ni, the probability is 1 over 6. So untuk getting 2 per 1 over 6, getting 3 1 over 6 until getting 6. Okay, also 1 over 6. So ini pun example of the classical probability. Tapi kalau you punya outcomes tu dia different. Contoh you punya outcomes, you ada 2 event. Event A dengan event B. Tapi you punya probability, one is 1 over 3. So another one is 2 over 3. So kalau probability dia not equal, okay, so ini kita tak consider as classical lah. Okay, so classical tu bila probability for every outcomes equal ataupun equally likely. Okay, so formula is number of outcomes in A. Okay, you can divide with the total number of outcomes in the sample space. Okay, so you can refer to example. Okay, example 2. Okay, so you need to draw a possibility space diagram. So ni between a coin and a die. Okay, so probability obtain a number less than 5. Okay. So example of the space diagram. So tak kisahlah you nak buat X the coin ataupun Y the die pun boleh. So depends. So kat sini you punya sample space. Okay, so sample space total we have 12. Okay, start from one head. Okay, maknanya kalau you baling coin dengan dice together, okay, so maknanya bila you baling serentak, dia pun ada possibility dia, you dapat one dengan head. Ataupun second toss tu, you dapat one dengan tail. Okay, so until you dapat 6 head or 16. So you dapat total is 12. Okay, lepas tu dia nak number less than 5. So number less than 5, mana you ada ini. Okay, 1 head, 2 tail until you dapat 4 head and 4 tail. Okay, so total we have 8. So nak calculate probability is 8 overkan dengan 12. So 12 tu is the sample space. Ini example of the classical. Classical sebab you punya dice ni, okay, dia punya probability dia semua sama. Coin pun probability dia semua sama untuk head dengan tail. So you boleh pakai formula ni. Okay. And next we have obtain a tail and a number at least 2. So dia nak a tail and a number at least 2. Okay, so ni you punya outcomes of the event. So total is 5. So answer today is 5 of it. Okay. So classical probability can be found also by using tree diagram. So ni kita akan pergi nanti 7.3 using tree diagram. Next, for second types of probability, kita ada empirical probability. So empirical ni based on observation or the relative frequency. Okay, so formula dia is frequency for the class over with the total frequencies in the distribution. So empirical ni biasa dia bagi you in terms of table. Okay, so kita boleh apply law of large number. Okay, so law of large number ni sama untuk solve untuk yang empirical lah. So you boleh dapat sign interpretation macam ni. Okay, so ini symbol for equal, so this one symbol for less than, so ni for greater than, and number 4 ni symbol for at least. So kalau A is at least 10, so A greater and equal to 10. Okay, so kalau A is at most 10, so A must be less and equal to 10. So you can alert these two lah. Sebab student silap ini dua ni. Okay, kalau less dengan more than tu saya rasa you boleh lah untuk less dengan more than tu. Cuma at least dengan at most ni. Okay, jangan tertukar. So ni untuk start interpretation. Lepas tu you ada example 3. Okay, so you have frequency distribution. Okay, so total is 85. Okay, so based on this information, find the probability that the family has monthly income at most 15,000. Okay, so dia nak paling banyak 15,000. Okay, so you boleh calculate. So kat sini lah 24 plus 39 plus 13. So semua tu you overkan dengan 85. So you have 76 over 85. Okay, lepas tu dia nak income more than 20,000. So more than 20,000, kalau you refer this table, so yang ini is refer to more than 20,000. So you need to plus 2 over 85 plus 2 over 85. So you will have 4 over 85. Okay, so dia semua overkan dengan you punya total of the frequencies tu. Mana overkan dengan 85. Okay. Next, kita ada subjective probability. So, subjective probability ni yang third types of probability. Okay, so subjective probability ni dia based on individual belief je. Okay, contoh dia, kalau you ada, saya bagi kat sini. So, 30% chance the patient will need an operation. So, kalau saya base pada diagram, maknanya you ada operation dengan not operation. Okay. So kalau operation you ada 30%, also 3 over 10. Okay, so tak perlu operation is 7 over 10. So kalau tengok sini, dia dah masuk subjective probability lah. Okay, sebab dia tak boleh masuk classical. Classical dia mesti outcomes dia is equal lah. So kat sini dia punya outcomes dia probability is not equal. So first you ada 3 over 10, so another one you have 7 over 10. So kalau not equal ni kita masuk dalam subjective. Okay, sebab dia tak fix. Okay, macam tadi toss a coin tu memang dia always fix. Kecuali lah coin you tu kemik ke ataupun dia tak apa, permukaan dia tu tak rata ke, tu baru kita consider dia akan jadi bias coin. Tapi untuk general, kalau you baling coin, kita consider dia as classical. Okay, sebab dia tak ada bias buat mana. Tapi kalau kat sini dia ada bias. So sebab tu kita panggil dia subjective probability. Okay. So kalau you ada ni patient, contoh ni patient A. So kalau refer patient lain, patient B. So patient B mungkin lain pula, dia punya chance dia. Sebab tu dia subjektif, dia panggil subjective probability. Sama juga kalau second example, you ada earthquake will occur in certain area. So dia kata 80%. So 80% ni refer pada earthquake pada area tu je. So dia pun tak sama. Okay, contoh you ada earthquake dengan tak ada earthquake. So kalau earthquake you ada 8 over 10. So balance dia is 2 over 10. So ni kita panggil subjektif lah. Okay, dia tak spesifik. Dia tak always macam ni. So kalau kita tukar area, contoh area lain, so dia bertukar balik dia punya probability tu. Okay. So ni example of the subjective probability. Dia based pada you punya past experience je. Okay. Lepas tu kita ada rules of probability. So rules of probability, kita ada 4. Okay, so 4 rules of probability. Okay, first probability dia must be between 0 and 1. Okay, so dia tak boleh less than 0 or greater than 1. Okay, lepas tu you ada if A is an impossible event, then probability of A is equal to 0. So kalau impossible event, maknanya probability dia equal to 0. Kalau dia sure event, then probability dia is equal to 1. 1 tu maknanya confirm event tu berlaku lah. Okay. Lepas tu number 4, total probability of all outcomes in the sample space is 1. Okay. So tu you punya total outcomes dia. So dia always 1. Dia tak boleh less than 1 ataupun more than 1. So total probability dia mesti 1. Okay. So kita consider, okay. So rules ni dia apply untuk semua. Jadi kita ada 3 types of probability kan. Okay, you ada 3 types. You ada classical, empirical and subjective. So rules dia apply untuk 3-3. Tapi kat sini dia bagi example for equally likely ataupun classical je. Okay. Contoh inilah ni example of the classical probability. Okay. So kita ada 4 types of flowers. Okay. So what is the probability that Puan Salma chooses the sunflower? Okay. So kita ada total the rose, daisy, sunflower and orchid. So total ada 4. So probability of each is 1/4. So probability that she choose sunflower is 1/4. Okay, so kalau tengok dia mesti between 0 and 1. Okay, lepas tu number 2. Probability that Puan Salma choose all types of flowers. So maknanya all type of flowers 1/4 plus 1/4 plus 1/4 plus 1/4. So you dapat total dia equal to 1. Okay, so total of the probability must always equal to 1. Okay, so ni rules, ni 2 of the rules lah. Okay, so kita ada another 2. Okay, so ni untuk sure dengan impossible event. Okay, so example dia for B ni, you ada a plate contains 10 pieces of vanilla cupcakes. Okay, 1 piece of cake is taken randomly from the plate. So find the chances that the cake is vanilla cupcake. So kalau vanilla memang confirm lah sebab semua cake tu is vanilla. So you ada probability dia is equal to 1. Or dia nak probability yang strawberry cupcake. So ini consider as impossible. Sebab dia semua cupcakes tu vanilla, so tak mungkin you dapat strawberry cupcake. Okay. So probability you get for strawberry cupcake is 0. So yang ni kategori dia is impossible to happen. Okay, soalan tak so far? Okay, tak ada so yang chapter 7 ni you kena buat exercise nanti you nampak macam simple je sebenarnya tapi declaration dia semua simple je lah. Okay, tapi you nak faham dia punya soalan tu. Okay, tak apa nanti you buat tutorial nanti. Okay, so saya nak masuk 7.1.4 complementary event. Okay, so for complementary event, so the complement of event A is the event that A does not occur. So the complement of A is denoted by A bar or A prime. Okay, so saya rasa complementary event sekolah you dah belajar dah. Dia untuk event yang selain daripada A. Okay, so or in terms of Venn diagram, for example, this one is the event A. So A complement maknanya semua outcomes yang bukan daripada A. Okay, so tu for A complement. Okay, so rules for complementary event, probability of A plus with probability A complement is equal to 1. So ni you kena hafal jugalah. Okay, so from this formula you can derive what is the PA. So kalau probability of A equal to 1 minus probability of A complement, Or to find probability of A complement is 1 minus probability of A. Okay. So you can refer example 5. Okay, so you have the sample space, 1 until 6, so total you have 6. So let E, event that 5 will appear. So kalau 5 will appear, maknanya 1 over 6. Tapi sekarang dia nak yang probability that 5 will not appear. So you kena minus 1 total of the probability minus with the probability of 5 will appear. So you dapat 5 over 6. So yang ni kita consider as probability of complement lah. Okay, selain daripada probability for the event. Okay, sebab tu you kena minus. Okay, so ini for example 5. Okay, so saya nak masuk mutually exclusive event. Okay, so mutually exclusive event is the so kita pergi union dulu. Okay, union event. So union event is included in either A or B or both. So dia dua-dua include dalam A dan B ataupun dua-dua sekali. Okay, so notation dia kita pakai macam ni. So ni notation for union. Or you have A or B. Okay. So in the terms of Venn diagram, so ini example of the union. Okay, dia semua shaded region semua A dengan B. Next kita ada intersection event. So intersection event included in both A or B. So dia mesti yang dua-dua ada je baru you boleh consider as intersection event. Okay, so notation dia yang ini kita pakai intersect ataupun A and B. So in terms of Venn diagram, okay, so kita ada intersection ni yang tengah ni. Okay, so itu sebenarnya Venn diagram for intersection event. Okay, lepas tu kita ada additional rule 1. So ni formula pun you kena hafal lah, formula for additional rule 1. So ni kalau involve union and intersect. So you boleh apply this formula. Okay, so we have probability of A union B equal to probability A plus with probability B minus probability of A intersect B. Okay. So kita ada example. So example 6 ni saya nak refer kepada video je. Okay, so saya nak you tengok example 7. Okay, so for example 7 ni, kita ada total 25. So ni punya sample lah, dia ada 25. So daripada 25 ni ada yang study mathematics, ada yang study English dan ada juga yang study both mathematics and English. Okay, so M refer to study mathematics and E refer to those who study English. So given that total, so total student yang study maths is 12 and total student study for English is 70. So you need to find the probability of students studying mathematics and English. So kalau N makna you kena calculate using intersection. Okay. So first you boleh buat Venn diagram dulu. Okay, so Venn diagram dia, you have X. So intersection dia kita tahu lah kita nak calculate what is the X ni. So M dia makna 12 minuskan dengan X. E pun you ada 70 minus X. Okay. So you will get X dia is equal to 4. Okay, so you can dapatlah intersection that is 4 over 25. So kalau yang B, show that the probability of students in the class study mathematics or English. So kalau or English makna union. Kalau N, intersection. Okay, so kalau union you boleh pakai balik formula yang tadi. A union B equal to probability of A plus with probability of B minus A intersect B. So probability of A dah ada, in maths or English, so M intersect with E. So ini probability for M. So this one probability for E and then this one for M intersect E. Okay, so your probability of M is 12 over 25. So plus probability of E 17 over 25. So you need to minus with the 4 over 25. Okay. 4 over 25 minus 4 over 25. So 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 4 over 25 min So you nak show tadi kita nak show dia probability. So maknanya kau dapat equal to 1. Next kita ada mutually. Ni baru kita masuk mutually exclusive event. So mutually exclusive event, two events A and B are mutually exclusive or disjoint if events A and B have no common element. So in other words, event A and B cannot occur together. So A intersect B is equal to null set. Okay, ataupun empty set. So kalau kat sini equal to 0 lah. You boleh juga write down as A intersect B equal to 0. Okay. So in terms of Venn diagram, kalau you tengok dia tak ada intersection. So dia separate lah event A and event B. Okay, so ni example. So ni definition of the mutually exclusive event. Okay. So you have, next kita ada additional rule 2. So additional rule 2 ni, you tak nak hafal pun tak apa sebab dia sebenarnya refer pada additional rule 1. So kalau additional rule 1 tadi, kita ada A union B equal to probability of A plus with probability of B minus probability of A intersect B. Tapi sebab dia mutually exclusive, so intersection dia akan equal to 0. So you left with this formula je. Lepas tu you dapat formula ni. Okay, so ni formula for mutually exclusive event. Okay, so example ni. So ni saya nak refer recorded video. So example 9. Okay, so you ada outcomes dia 1 until 8. So you ada event A 5, 7, event B 1, 2, 5 and C 1, 4, 6, 8. So dia nak A and B. So kalau you refer A and B, mutually exclusive. So you kena check intersection. Okay, so kalau A and B dia ada satu intersection 5. So maknanya event A and B tu are not mutually exclusive event sebab dia ada intersection. Tapi kalau untuk yang B, event A and C. So A dengan C. So dia tak ada intersection. So you boleh kata event A and C tu are mutually exclusive event. Since A intersect C is equal to 0. Okay, so tak ada intersection, you boleh kata mutually exclusive event. Okay, so you nak calculate union, you boleh pakai formula yang tadi, additional rule 1. Okay, so you boleh pakai formula ni. So dapat 3/4. Okay, last. Okay, probability of event using Venn diagram. Okay, so yang ni probability of event using Venn diagram ni, yang ni kalau kita derive formula. So kalau kita tengok yang first ni, dia sebenarnya datang pada formula yang tadi. A union B equal to probability of A plus probability of B minus probability of A intersect B. Okay, so ini kena hafal lah untuk yang basic formula dia. Tapi for formula number 2, 3, 4 dengan 5, so you tak nak hafal pun tak apa. Okay, you boleh derive formula tu based on the Venn diagram. Okay, so example dia untuk yang number 2. Okay, you nak calculate probability for A complement intersect with B. Okay, so kalau saya buat Venn diagram, you ada two event A and B. Okay, so you ada event A and event B. First, you kena shadekan region lah. Okay, first you nak A complement. A complement maknanya region selain daripada A. So ini you punya region for A complement. Okay. Next, you need to intersectkan dengan B. So region for B yang ni. So you boleh nampak kat mana dia overlap. So dia overlap dekat region yang ni. So to calculate this region, dia also equal to probability of B. So probability of B minus dengan intersection. So you can dapat region yang shaded tu. Okay, shaded region. Sama juga number 3. So kalau number 3, you nak calculate for probability of A intersect B complement. A intersect B complement, kalau based on Venn diagram, okay, so you ada event A and B. So first you shaded region A. Okay. Next, region for B complement. So B complement elements lain daripada B. Okay. So sama juga, you akan tengok yang overlap is this region. Okay. So this region means that probability of A minus with, so probability of A minus with probability of A intersect B. Okay. Ni for number 3. So kalau number 4, contoh number 4, saya buat di sini. So you ada number 4. So number 4, example, you nak calculate probability of A complement intersect with B complement. Okay, so kalau based on Venn diagram, okay, so event A and B. Okay, A complement elemen selain daripada A. Yang ini for A complement. Next, we have B complement. So B complement selain daripada B. Okay. So you boleh tengok yang overlap dia dekat luar ni je. So yang overlap dekat sini. So that's why formula dia, we have 1 minus with probability of A union B. Okay, so ini for formula number 4. Next, for last formula. Okay, you have probability of A complement union with B complement. Okay, so beza dia kalau number 5. So beza dia tadi number 4, we have intersection. So ini for union. Okay, so you punya Venn diagram pun sama. You have 2 event, A and B. Next, we have sample space. So event A, event B. So you need to shaded region A complement. So A complements. Okay, so ini event lain dari A. Okay, and B complement. So B complement this region. B complement is this region. Okay. So shaded region sama macam yang tadi, yang number 4. Tapi sebab yang ini intersection. So intersection, you kena tengok yang shaded region yang overlap. Tapi kalau union, you kena tengok shaded region yang semua shaded region. Tak kisah ada overlap ke ataupun tak. Okay. So kalau tengok yang ini, shaded region ni semua yang ni. Yang tak ada shaded region, yang intersection yang tengah ni je tak ada shaded region. Okay. So formula dia is 1 minus dengan probability of A intersect B. Okay, so minus dengan yang center ni intersection. So nanti you akan dapat semua region. Okay, so ni kalau you nak base pada Venn diagram. Okay, tapi depends lah, kalau you tak nak pakai Venn diagram, you boleh hafal formula ni. So you boleh hafal this 5 formula. So formula so penting formula number 2, 3, 4 dengan 5. Okay, so itu example. Okay, next example. Example 10 tu you boleh refer ke kolom. Okay, so ada soalan tak? Kalau you ada. Okay, so tak apa. So kita stop dulu kat sini. Pening lama-lama banyak kan. Okay, so yang lain tu nanti kita akan continue next class. Okay. So thank you semua untuk yang ada lah.
Thank you, madam.
Thank you.
Thank you.